In this video, I will give an introduction on using LTspice. So you want to go download LTspice. What you can do is just go to a search engine and type in download LTspice. And this is the website you want, this analog.com. Click on that, scroll down to download LTspice, and then click on your operating system. So like download for Windows 7, 8, and 10, and it'll basically download the executable file, and when that finishes, then you just double click that and run the it'll set up the software. So you would just come here to downloads and basically just double click the icon, and it will install the software for you. Okay, so this is what it looks like, LTspice XVII. So we'll double click on that. And when it comes up, you've got this just blank canvas here. And at this point, we need to actually create a new schematic. So we'll go File, New Schematic. And now this becomes a different looking background. So up here you can see that it's called Draft 1. So that's what it gives it by default. If we want to save this file, go to File, Save As. Let's just save it to Documents, and we'll just call this Demo. And it saves it as a .asc file. So we're going to save that in Documents. And now you see that the file name gets updated to Demo up here on the top left. Alright, now it's time to actually build just a simple circuit. I'll do a simple series circuit with just resistors. So we're going to need a few things. We're going to need to go to Edit, Component, and in Component you can select all these different type of components. So select component symbol. We're going to need a voltage source, so I'm going to hit voltage, OK. Then I'm going to move my mouse and then left click. By default, LTspice will assume you want to add another component of the same type. In this case, I don't. So what I can do is just right click and get rid of the extra component. Now I also need a ground. I can either select a ground here or a resistor here. So you've got some kind of shortcuts up here. But you can always go to Edit Component. And you can see that here we have a let's see, ground. Ground may not be up here. We've got resistors for sure. Resistor I could add here. So I don't know, maybe ground may not be up here in the component section. But what you can do is hit cancel and just click the ground here and add a ground there. I'm going to add another one over here. And again, I don't need this third ground, so I'm just going to right click. Now I could go to the edit component, pick the resistor, but it's faster just to grab the resistor up here and left click. Now it's oriented vertically. If I want to change this, I just hit Control R. Control R will rotate it. So I'm going to add 1, 2, 3, and then I'm going to rotate this one and add a 4th resistor. I might move this over a little bit here. Again, I don't need a 5th one, so I just right click. To move a component, you come up here to this hand, see where it has move, left click the move, and then basically left click and drag and select what you want to move. And I want to move the ground here, and then right click to get back to the default. Now we need to connect everything up, so we're going to use the wire tool, and you just left click on the terminal and drag, and then left click, drag, left click to make a turn, left click, drag, left click, drag, left click, and then right click to get rid of the add wire tool. Okay, the next thing we have to do is we have to put in some actual values. These are just, they don't have any actual real numbers. So the way you do that, you right click on the component, voltage source, let's make that 10.0, hit OK, and resistors, let's make this say 820, let's make this one 1.2 E3. 1.2 E3 is K, so it's times 10 to the third. So this would be a 1.2 K ohm resistor. Let's make this say 220, and we'll make this 3.6 K. And I'll go up here and just click on the save icon. Okay, so now we've got a complete circuit that we can simulate. So to do that, we need to go to the simulate menu option and choose edit simulation command. And for this analysis, we just want to do a transient, which just means we want to just run it for a certain amount of time and see the results. So because this is at DC, I'm just going to run this for say 10 milliseconds. So I'll do 10 e minus 3. So that's 10 times 10 to the minus 3, so that's 10 milliseconds. Hit OK. And that's it. Save it. All right, now we're ready to, and to move this around, if you just left click and drag, you can move the whole circuit around. Just a left click and drag. All right, to simulate it, we need to click on this run command or this run option. You could also do it here under simulate run, and that brings up a waveform window, and you can see that it's 10 milliseconds on the horizontal axis. And now we can look at the current, the voltage, and the power. So if you just hover your cursor over each resistor, then you can see in the bottom of the window, you can see the current and the power that's being dissipated. And so you can see that down on the bottom. So for instance, for R3, I can see that the current is 1.71 milliamps and the power is 645 microwatts for the dissipation. Now, one thing you'll notice here is a current showing up as negative. And the reason for that is if you look at your cursor, you can see that the arrow is pointing to the left over each resistor, and it's pointing up on the R4 resistor. And we want these to be pointing in the actual direction of conventional current. This is showing electron flow, and we want this to show conventional flow. So what I'm going to do is close out my waveform, go back to my circuit, select the move icon, click and drag, and rotate all of these using Control R, 180 degrees. So I'm going to grab all these and use Control R twice for 180 degree rotation. And save it and run. So now you can see that the arrow is pointing in the proper conventional flow direction. Okay. So again, you can just read off here, IR1, you can see is 1.71 milliamps. So the current's going to be the same because this is a series circuit. The other thing you can do is if you left click, it'll display the current in the waveform. And here you can see it's between 1.6 and 1.8. And to get an exact reading, we can just right click on this IR1 and do attached cursor. And this will show us the actual precise value of what it is. 1.71 milliamps here. Now to get rid of something, we're going to use the cut tool. So let's hit cut. You get a pair of scissors and you can just cut that waveform. And then hit right click to get rid of the cut. So you can either go back and select this window. You can either hover the mouse or the cursor over the resistor to get the current and power, or you can left click to get the current to display. And I'm going to delete that. What about voltage? So to get the voltage, you need to click and drag. So I'm going to left click on the left side of R1, click and drag, and when the lead becomes black, I'm going to release. So that's showing me about 1.40 volts for our VR1. Let's see what VR2 is. VR2 is the blue, and that's just over 2 volts. And I can go ahead and delete these. And VR3 is about 376 millivolts. And VR4 is up just over 6 volts. This is VR4. So that's the way that you can see what the voltage is. So again, just to recap, if you want to know the current or the power, you can just hover over the resistor and that will show up in the bottom of the schematic window. If you want to know the voltage, you need to left click and drag and release to show the voltage up in the waveform window. So that's all there is to it for creating just a basic series circuit with resistors. Just to show you one more quick thing, for a circuit like this where we just want to know the operating point, we could actually just do a steady state simulation. So if I go back to simulate, edit simulation command, and just click on DC operating point, then that will show me the values here. So if I click OK, operating point, and do a simulate, then all the values show up in this nice little chart here. Alright, so that will end this tutorial, and I hope that this has been useful for you.